In this tutorial, we're solving a power problem, and our prompt is that an 85 kilogram person is lifted up in a 1,000 kilogram elevator. The person is lifted 12 meters in a time of 5 seconds. How much power is delivered by the elevator? So we'll draw our diagram here. Here's the elevator, the person inside. If we draw our free body diagram, we have a gravitational force pulling down, and we have an applied force from the elevator pulling up. And most elevators move at a constant speed, and therefore the applied force would balance out the gravitational force. We write down that we have a mass, and we have two masses, mass of the person and the elevator. So we want a total mass. We add them together, the 85 and the 1,000, to give us a mass of 1,085 kilograms. We also know that they are lifted 12 meters. That is the distance lifted up. And it's a time of 5 seconds. So our delta T is 5 seconds. We want to find how much power is delivered by the elevator. So we are finding the power in this problem. Now, in order to solve for the power, we need to know the work and the time. We do know the time, but we do not know the work. To get the work, we need the force times the distance times the cosine of the angle. I know the distance, but I don't know the force. I do know that the force here is balanced out by the gravitational force. If we write this out, the total force in the y is 0 because, like I said, most elevators move at a constant speed, and therefore our applied force, which is up, and our gravitational force, which is down, total 0. And so our applied force equals the gravitational force. But I don't know the gravitational force, I know the mass. So to get the gravitational force, we multiply the mass times the gravitational field. So we take our 1,085 kilograms and multiply by 9.81 newtons for every kilogram. We get our gravitational force, it comes out to be 10,644. And that would be units of newtons. And so therefore we also know that our applied force is also 10,644 newtons. Now our next step is to get the work. So work is force times distance times the cosine of the angle. In this case, we're using the applied force because we want to find the work done by the elevator. So we write this out. We have the applied force is 10,644 newtons. We know that the distance is 12 meters. And we know that the angle here, since it moves up and the direction of the force is also up, if it moves in the same direction as the force in your equation, the angle is 0 degrees. So we get our work comes out to be 127,726. And since we kept things in newtons and meters, we get joules for our units of work. Our final step is to solve for our power. And our power is the work divided by the time. Now that we know our work from before, it is 127,726 joules. And we know our time over here is 5 seconds. We get our power to be 25,545. And since we kept things in joules and seconds, a joule per second is abbreviated as a watt.